This video is going to teach us about prime and composite numbers. Prime numbers are numbers that can only be created by multiplying 1 and the number that we're looking for, I'll call it n for this video, is the only way to get to whatever number that we're trying to get to. Composite numbers are a little bit different. So, composite numbers can be created by two other numbers that are not 1 or the number that we're looking for to get us to that number. Again, we'll keep calling that n. So these two numbers are different than either 1 or the number that we're actually looking for. So let's see how this works with some actual numbers. So, for example, the number 2. Are there two numbers that can multiply together to give us 2? Well, the only ones that exist is 1 and 2. So, because of that, 1 times the actual number that it is going to give us that actual number. So that means that 2 is a prime number. If we're looking for ways to get to the number 3, the only way to get there is, again, 1 times 3. So 3 is a prime number. The number 4, you'll find, is a little bit different. We can, of course, get to the number 4 by multiplying 1 and 4, and that will get us to 4. But there's another way to get there. If we multiply 2 by 2, that will get us to 4. So, as you can see, 4 is a composite number. There's more than that way to get us to 4. So 4 has to be considered a composite number. If you keep going, you'll find that 5 can only be created by multiplying 1 times 5. However, 6 can be created by multiplying 2 times 3, as well as 1 and 6, of course. So, how do you go about finding out if a number is prime or composite? Well, let's, for example, look at the number 15. So, obviously we know that 1 times 15 is going to get us to 15, but we want to know if there's two other numbers that will get us there. So, to start out, we'll use the next number up, so number 2. Is there anything that a 2 can multiply by to get us 15? Well, 2 times 7 would get us 14, which is a little bit smaller than 15, and 2 times 8, the next number above 7, would get us 16, which is too big. So 2 is not going to work. What about the number 3? Well, if we multiply 3 times 5, that will get us 15. So 3 times 5, we automatically know that 15 must be a composite number. You can continue on and try to find any other factors. If there's anything that multiplied by 4 to get you 15, or we already know 5 does, 6 multiplied by anything, 7 multiplied anything to get you to 15. One place that you know is a good time to stop is once you get halfway to that number, because we know that 2 has to be multiplied by something to get you to 15. So if you're bigger than half that number, so for example, halfway to 15 is 7.5. So if you're trying to multiply something by 8, well, the smallest number that we can multiply, other than 1, to get there is 2. So you know that 8 can't possibly be a number that would get you there. Anyways, this is one way we'd know to get to a composite number. If you were looking for a different number, for example 13, you could try the same strategy. You'll find that, of course, 1 times 13 will give you 13. 2 times 6 will give you 12. 2 times 7, the next number bigger than 6, will give you 14, so 2 can't work. The number 3 multiplied by 4 will give you 12. The next bigger number, 3 times 5, would give you 15, so that can't work. If you're trying to multiply number 4 by something, if you multiply it by 3, that'll give you 12. If you multiply it by 4, that'll give you 16. So clearly, those don't work. If you multiply 5 by 2, that'll give you 10, which is too small. And if you multiply it by 3, it'll give you 15, which is too large. So that doesn't work. Now we're up to the number 6. If you multiply that by 2, that'll give you 12, which is just a little bit too small. And if you multiply it by 3, it'll give you 18, which is way too big. Which brings us to our last number, the number 7. And if we multiply 7 by 2, that would give us 14, which is obviously too big. And we know anything after that because, again, 2 is the smallest number that we can use to multiply things by. Any number then after that is obviously going to be too big. So we know that only 1 and 13 can multiply us to give us 13, so 13 must be a prime number. Work through several numbers to see if you can find a chain of prime numbers. You'll find as you go up, you'll find that there's many prime numbers. As you get bigger, there become more and more composite numbers, but there are prime numbers well into the thousands, millions, billions, and even beyond that. So there are all sorts of prime numbers out there, but composite do become more common as the numbers get bigger. I hope this helps trying to find prime and composite numbers.